Today I want to just clarify the three types of normal curves that we've been studying just to make sure everyone really understands the difference. So we've looked at standard normal, normal, and sampling distribution. So let's start to really look at them a little closer. First I want to ask, how do you describe each one? So really, how do you describe a normal curve? So to describe a normal curve, you just state the distribution. And when I say that, lots of times like, what in the world is state the distribution? Well, state the distribution is stating the two things that really define the look, the shape of a normal curve. And the first thing is your center, which is usually our mean. Okay, so that goes first. And then the second thing is a standard deviation. And we write it just like you see right here, n parentheses, comma, and this is the format I want to see. So when I say describe the curve or state the distribution, I'm looking for this. So the first type of normal curve is the standard normal. Here's your distribution. Now the standard normal just tells you about the z-score. So anytime I'm dealing with z-scores, I use a standard normal. Okay, it's a great way to use things because then it doesn't matter if we're talking about the units of measure, whether it's seconds or feet or the exact points you got. All I'm looking at is how far are you, how many standard deviations are you away from the mean? 1, 2, 3, and we know these are pretty extreme values. So again, standard normal is just all about the z-score and the number of standard deviations, and there's your distribution. Standard normal is really excellent. We talked a lot about events in the decathlon and how you really can compare how somebody has done between, say, the high jump and the 100-meter dash. So to do that, you can actually just turn your scores, which might be in feet or seconds, into z-values, and then you just get your standard normal. So it's really great for comparing different types of things. The normal curve is what we deal with the most often. It's when your data, in order to use it, you have a big data set, and you just need to make sure that data is relatively symmetric and unimodal. So you just kind of make a histogram, check on that, and if it is, you can model everything and make predictions based on the normal curve. It's really got a nice basic distribution. It's just your mean and your standard deviation. And you can just set it up like this. So the normal curve is what we see the most often. And we really use it when we're just asking about one person. Like if I said, you got a score of, if this was our exam with 52 as our mean and this is our standard deviation, and I said, you have a score of 60, what is your percentile? I would use it here, okay? A different one is the sample distribution curve. Now this is pretty different. This is what we expect from a group of people. So this word is really important, a group of people. So this is when I'm not going to be asking about just your score. Instead, I might be saying, well, period 8 has 25 people in it. I want to know I'm trying to predict the average score for that group of 25. So I'm trying to figure out one number that represents the group. And when I'm doing that, I can't just use that basic normal curve. I can't use the standard normal. I need to use a sample distribution curve. And for this curve, I'm going to use these distributions. I'm going to describe the distribution either like this if I'm talking about means. So that would be like a score in a test. Or I'm going to describe it like this when I'm talking about proportions. And that would be like the percent of people who smoke or the percent of people who have their driver's license. So the thing that can get confusing is what's the difference between a normal curve and that normal sample distribution. So I just want to clarify that again. The normal curve is when you're just looking at one person or one event. All right, and we describe it with this distribution. The normal sample distribution, if we're just talking about means here, is described like this, and it's when we're looking at a group. All right, and so the key difference here is just how you're counting out along the normal curve. So that standard deviation, that unit of count, is going to be smaller when you're looking at a sample distribution because you're dividing by the square root of n. All right, so if we look at an example, we have the number of days a woman is pregnant can be described by this distribution right here. And I ask you, what is the probability a woman will be pregnant longer than 280 days? So here I'm asking about a woman, just a single person. So I'm going to be using a normal curve. All right. Now say I ask this question. A study is conducted on 60 women. What is the probability that these women will be pregnant less than 260 days? Excuse the typo there. So now I've got a group of people I'm talking about. So I'm talking about a group. I'm going to go to this distribution. So I'm going to change the unit I'm counting out by. I'm going to change that standard deviation and divide it by the square root of n, which in this case it's going to be dividing it by the square root of 60. All right, so I hope that is clear for all of you. The key thing for you to really remember here is going to be the 3 types of normal curves and how you actually describe them. Again, remember using that form.